Alright, for this video, continuing with word problems, we're going to go over what's called consecutive integer problems. I will say on this sheet there's a lot of problems and there's not a whole lot of space. Now I'm going to try to squeeze it in here, but it'd be smart for you to either put it on the back side of this where you have space, or just put it in your notes. Put it in your notebook so you have a lot of space. Okay, what I'm going to go over first, you don't have to take down. Let's first kind of come up with, what does consecutive integers mean? Well, integers, those are whole numbers. They can be negative, it can be 0, it can be positive. Consecutive means it's one after another. So here's an example. Here's consecutive integers. 1, 2, 3, 4. Right? They're one after another. Now, it's real easy to figure out like what the next one would be. Well, you would just add 1. So you just keep adding 1 to it. So 5 plus 1, 6, 6 plus 1, 7, and so on. Now, if you didn't know what these were, if the numbers were, let's say I said that x was 1. Well, if you wanted to put this in terms of x, to find the next consecutive integer, it would be x plus 1. Right? Because 1 plus 1 is 2. Then you would add another 1 to this. So if you add 1 plus this 1, then it's x plus 2. This is going to be real important because you're going to set this up using x's in your equations. Then you would have x plus 3. So this is if you just had consecutive integers. Alright? Now if I look at this first one, we can squeeze this in. It says, write an algebraic phrase for each of the following. It says the sum of two consecutive integers. Well, consecutive integers, I could say, the first one, I don't know what these are. Since I don't know if x is 1, 2, 3, or 4, or 5, the first integer is always x. Always, always, always. The second integer, since it says they're consecutive, they're one after another. So this is what we're going to get. We're going to get x plus 1. So the setup is very, very key. Then it says the sum. Well, sum, that's key word for adding. So all this means, I'm going to add x plus 1. And that's it. And I know if you added these, you can combine these x's. X plus x is 2x, so you get 2x plus 1. So that's your answer for that. Now next, what we're going to do is, now we're going to look at even and we're going to look at odd. And the setup's going to be a little bit different. So I'm going to erase what I just did, and now I'm going to look at even and odd. Alright. Okay, let's look at an example of even integers. Let's say I just start with the number 2. Well, if I had the number 2, I know the next consecutive even integer would be 4. Then 6, then 8, then 10, then 12, and so on. Here's the common thing now. Now they're not one after another. You have to add 2 to get the next even integer. So 2 plus 2 would give me 4, 4 plus 2 would give me 6, and so on. So the first integer is still going to be x. But now here's the difference. Since we're going up by 2 to get the next even integer, instead of doing x plus 1, the next integer is x plus 2. And then the third integer, well, if I add 2 to that 2, it's going to be x plus 4. So when we do word problems with consecutive even integers, this is going to be the setup here. The x plus 2, x plus 4, x plus 6, x plus 8, and so on. So I'm just going to put the setup here that says the sum of 3 consecutive even integers. Well, these are going to be my 3 right here. Now, since it says sum, you guys hear the bell there. Okay, since it says sum, we're going to add all these up. So it's going to be, again, I'm going to squeeze this in, x plus the second integer, which is this, x plus 2. The third integer, which is this, which is x plus 4, and I add those up because it says the sum. And then if I combine like terms, I have x plus x plus x, so that gives me 3x. And then I have 2 plus 4, which is 6. So this is my answer for number 2, 3x plus 6. Alright, then we're going to do number 3, and then we're going to call it quits. When we get into part B, we'll do those in class first thing tomorrow. Let's just do number 3. Again, I'm going to erase everything, so if you didn't get this down, you can pause it, take it down, or rewind it, take it down, whatever you have to do. Work at your own pace. Alright, let's do number 3. Now we're looking at consecutive odd integers. Let's first come up with an example. Okay, consecutive odd integers. Well, I could start with 1. The next odd integer is 3, then 5, 7, 9, and so on. You get the idea. Now, just like consecutive even, to get the next consecutive odd, you have to add 2 to it. So if we start with this 1, when I add 2 to that, I get 3. When I have the 3, I add 2 to that, I get 5. So it's still going to be the same setup as consecutive even. I'm always going to let the first integer equal x. Always, 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 always. You let the first integer equals x. Now second, it's going to be the same thing. I'm assuming that x is odd, so I have to add 2 to it, so it's x plus 2. Okay, again, I'm going to squeeze this in. Third integer is going to be x plus 4. And the fourth integer now, since we're adding in a fourth for number 3, this is going to be x plus 6. Now, a common mistake is students, what they want to do is if they see odd, they make this a 1, a 3, and a 5. This can't be 1 because then it's just 1 more than this x. It's got to be 2 more. So if it says consecutive even or consecutive odd, it's always the same setup. X, then x plus 2, then x plus 4, then x plus 6. Now again, same thing for 3. It says the sum of 4 consecutive odd. So I'm just going to add all 4 of these up. Now if I add this x plus this x plus this x plus this x, I have 4 of them. So it's 4x. And then I'm going to add the like terms. So 2 plus this 4 plus this 6. Let's see here. 2 plus this 4 is 6. 6 plus this 6 is 12. So I have 4x plus 12. All right, so we're not going to solve any equations yet. We're not going to solve for x. We're going to first go over these concepts to see if you really understand it. And then we'll look at B when we set up equations for it and we solve for x.